Hello, welcome to Artificial Intelligence and Machine Learning Week. In this video, I'll introduce you to the basic concepts of AI and machine learning and their applications. Nowadays, AI is no longer an unfamiliar term to us, right? Thanks ChatGPT, I guess. But AI has been around for a long time and is abundant in our life. Let's start with a quick game. How many of these examples can you identify? So the first one on the left, that was in 2011 when IBM Watson, an AI machine created by IBM, beat two Jeopardy champions in Jeopardy by a very large margin. The second one was in 2026 when Google DeepMind AI program, AlphaGo, beat Lee Sedol, the strongest Go player in the world, in his own game. The third photo, well, everyone probably knows this. It is Siri, or Hey Alexa, or Hey Google, or Content. They're all the same digital assistants that use AI to answer us in our human language. The fourth one, well, our famous Terminator and his nemesis, Skynet. Both AI products, machines that can act like humans, or in this case, better than humans. The fifth one, Tesla, autonomous driving cars that uses AI algorithm to navigate. And the last one, which is probably also used by any of us, Amazon recommendation system, also an AI product. It learns from behaviors and behaviors of other people like you and predict what you like to make recommendations. What do these examples tell us? That AI has been in our life for a long time. In fact, it started in the 1950s when the first artificial neurons paper and intelligent machine papers were published. And the term AI was coined in 1955 by Professor McCarthy. So what is artificial intelligence? In the simplest terms, they are machines that are capable of performing human-like behaviors, or behaviors of intelligent beings, as what we like to call ourselves. In other words, it can learn and act like humans. The AI domain is very vast and still developing. There are several ways to classify the types of AI. Based on capabilities, there are three types. Artificial narrow intelligence, where the machine is specialized on one area or one problem. Artificial general intelligence, where a machine can act like human in most areas and tasks. And lastly, artificial superintelligence, where a machine is much smarter than human in every way. The first one, artificial narrow intelligence, is what we are seeing today. The other two are still very much fictional, especially the last one. Think about Skynet. Under artificial narrow intelligence, the first type, you might also have heard other terms like deep learning, natural language processing, machine learning, and neural networks. And we have learned about supervised and unsupervised learning models. Those are the foundations of AI. And AI needs to have these abilities and models to be able to perform. It needs natural language processing to communicate successfully like humans. It needs machine learning, deep learning, and neural networks to detect patterns and adapt to new circumstances, and computer vision to understand and process images. At the end of this video, you should be able to distinguish these terms: AI, machine learning, and generative AI. This chart depicts the order of these terms. AI is the broadest domain or concept that refers to machines that are capable of human-like behavior. Machine learning is a subset of AI that uses unsupervised and supervised models to analyze past experiences and make future decisions. Neural network is a type of machine learning models that works similar to neurons in a human brain to analyze data. Deep learning is a type of neural network model with more than 3 layers to help in more complex ways. Lastly, generative AI, which is what ChatGPT or DALL-E or Bard are, is a type of deep learning models, a type of AI that can generate new content, for example, text, images, videos, etc., given the input. Let's take a look at this one example. Do you know what these are? They are images generated by DALL-E 3 in Bing Chat. Can you guess what was the prompt I used? Generate an image of Professor Hata, a Vietnamese female professor who is teaching logistics at Florida International University. She's paragliding in the galaxy for the first time. So what did you think? Okay, for the first look, right? Maybe some bias. The professor got to have glasses. Or logistics on the vest. A lot of rooms for improvement, but a good start. The more specific your prompts are, the more desirable the result you're gonna get. This is another example of generative AI in business. This is how Einstein, a new Salesforce generative AI product, can help you generate emails to your customer. Einstein uses a prompt template that it generates and grounds it with customer data and all other business and event data it has in the database, and instantly generate the email for you. So a sales executive like you doesn't have to even write the prompt in this case. So how does generative AI work? Very similar to other machine learning models. First, it is an architecture, hardware, software, machine learning, neural network models, etc. While the AI concept is not new, the growth of AI that we are experiencing right now is first thanks to the advancement of architecture, particularly the advances of computer processing power and cloud computing. Second, thanks to big data. The building of any AI model starts with a large amount of data and pre-training phase, in which it reads in massive amounts of data, text or images, and figures out the pattern on its own in an unsupervised manner. For example, GPT-3 used about 300 billion words to train. A side fun fact, do you know how long it takes for a human to read 300 billion words? About 2,378 years non-stop, assuming he or she can read 4 words per second. In the pre-training phase, generative AI is trained to generate output responses that resemble what it has seen previously. Generative AI uses a blend of supervised learning and unsupervised learning models to, for example, predict the next word in a sentence, given the previous words, and figure out the structure of the language without explicit instruction or labels. They are like voracious readers, absorbing vast amounts of text data and learning the rules and patterns of language along the way, all without a teacher explicitly telling them what to do. The models are then fine-tuned using more specific data and perform in a specific task. The models then are used to make predictions on unseen data and being deployed in different applications. The final step is the installation of guardrails and content policy to control the input and the output. This step begins during the fine-tuning, but continues well beyond that phase. Why do we want or need AI? AI is used everywhere in most large companies. and in different domains nowadays. It helps create profits by giving insights to user behaviors, improving productivity, and reducing human error through automation. A recent study by McKinsey estimated that AI could deliver $17 to $25 trillion a year. That's about the size of China's or the US entire GDP last year. Among that, generative AI's impact is about $2 to $4.4 trillion. The impact of AI spans multiple functions, including supply chain or finance. But generative AI alone could drive the most values for customer operations, marketing and sales, software engineering, and research and development. That could account for approximately 75% of the total annual value from generative AI use cases. While AI and generative AI hold immense potential, they are not infallible. Developing responsible technology is not just an industry issue, but a societal imperative. Professional top concerns related to AI are accuracy, data security, and ethics. To address these concerns, we need to develop more regulations, policies, and training. How much of AI power is harnessed and how much better it makes our lives really depends on us.